Chapter 10.2, Measuring Angles and Arcs. If we sum all the central angles, and looking at the picture we're given, angle 1, angle 2, and angle 3 are central angles. If we sum them all, it will equal 360. Looking at the first problem, and I look at diameter RV, if I sum these three angles here, it's half a circle, which would be 180. So 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180. Combining like terms, we have 26x minus 2 equals 180. And we end up with x equals 7. Looking at the next problem, if I sum these three angles, again it's a half circle. So 75 plus 5x minus 5 plus 7x plus 2 equals 180. Solving that for x, I have x equals 9. A minor arc is an arc that is less than half a circle. A semicircle is an arc that is half the circle that has the endpoints on a diameter. A major arc is an arc that is more than half a circle. The degree of an arc is the same degree, or the measure of an arc, as the central angle that it cuts off. In our first problem, we're told that WC is a radius. Identify x, z, y. So x, we go in the direction of z through y. We want to identify as a major arc, minor arc, or semicircle. So x, z, y, arc x, z, y is a semicircle. And the measure of x, z, y is 180 degrees. Again, we're told that WC is the radius of circle C. We want to identify arc WZX as a major arc, minor arc, or semicircle. So WZX, W going in the direction of Z. So starting at W going through Z to X, that arc is a major arc. And the measure of WZX would be 90 plus 180, which is 270. The last problem here asks us to identify XW as what type of arc. XW is here, it is a minor arc. And the measure of XW is 90 degrees. As we work through these problems here, I was hoping that you take notice of the notation, how you write an arc, and how you write the measure of an arc. For the next problem, we're told that LP is a radius. We want to identify LO. LO is a minor arc that is 90 degrees. We want to identify arc MLO. So we start at M, go through L, go to O. It is a semicircle, 180 degrees. The last one is LNO. Start with L, go through N to O. That is a major arc and 270 degrees. The next one is telling us that if we have the same circle or congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So for example, if angle 1 is congruent to angle 2, the central angles, then the arc FG is congruent to the arc JH. We can also add any of the arcs together to form a new arc. So for the next one, we're asked to find the measure of arc LHI. Well, if this is 90 degrees here, this also has to be 90 degrees. So the measure of arc LHI is 90 degrees. In the next problem, we want to find the measure of arc IJK. Arc IJ, this arc is 90 degrees. This arc right here would be congruent to this arc, so we could find out the measure of that arc if we wanted to. Or we also know that if we look at 32 degrees plus 90 degrees plus this arc, all has to equal 180, and that would help us find it too. But if I look at this arc right here, this is 90 degrees. If I do 90 minus 32, I have 58 degrees. So this would be 58 degrees because of vertical angles. This is 90 degrees. So the measure of IJK would equal 90 plus 58, which would give us 148 degrees. We want to find the measure of arc EAB. That would be 90 degrees. We want to find the measure of arc BCD. If this arc right here is 90 degrees here, we do 90 minus 38 degrees. And that would give us that this right here is 52 degrees, which would make this arc also 52 degrees, or that angle, because vertical angles are congruent. So 90 plus 52 would give us a measure of 142. The arc length is not the measure of the central angle. The measure of the central angle is in degrees. The arc length would be, what if you start at one end of the arc and walk to the other one, so you're measuring it in feet or inches or meters. We do this by setting up a proportion that the length we're looking for over the circumference would equal the arc measure in degrees over 360 degrees. So looking at the first problem, we're asked to find the arc length of arc AD. We know that the measure of arc AD is 40 degrees. So we want to find the length. So it's the length of the circumference, which is 2 pi r, and r in this case is 4.5, equals 40 degrees over 360 degrees. So we have 9.5 pi equals 40 over 360. Multiply both sides by 9.5 pi. We'd have that the arc length is exactly pi. So the length is pi, which is approximately 3.14. We want to find the length of DA. If this length right here is 28 degrees, or that angle is 28 degrees, that would make this angle here 152 degrees, because they have to add up to be 180. So we have the length over the circumference, 2 pi, and the circumference is, or the diameter is 12, where the radius is 6, equals 152 over 360. Multiply both sides by 12 pi. We have the length is approximately 15.92. In this problem, again, we want to find the length of arc DA. So the length over the radius, which is 2, or the length over the circumference, which is 2 pi 6, equals 140 over 360. 2 times 6 is 12, so multiply both sides by 12 pi. We have that the length is approximately 14.66. To set this one up, we have the length over the circumference equals 36 over 360. The length is approximately 3.77 centimeters. We want to find the length of JL, arc JL. So 180 minus 22 gives us 158 degrees for this angle. Multiply both sides by 28 pi. We have the length is approximately 38.61 centimeters. And the answer to this one is 32.99 centimeters. And that concludes our lesson for 10-2.